NASA has shown us that ours is a precious planet.
NASA has unique capabilities because we have the point of view from space. With NASA's carbon monitoring system, you can see the amount of CO2 in the atmosphere decreasing in the spring and the summer. Plants of the oceans and the land surface are greening up and pulling the carbon dioxide out of the atmosphere. And then in the fall and in the wintertime, you'll see the CO2 in the atmosphere increasing because plants and animals are releasing the carbon dioxide that was captured during the growing season. There is a graph called the Keeling curve where you can see the summer and winter cycle. The process is very natural. Contrast that with old slow carbon. So this is a chunk of coal. It was also made by plants. It also contains carbon dioxide that was in the atmosphere. But the carbon in this chunk of coal was taken out of the atmosphere 350 million years ago. And since the Industrial Revolution, we've been taking it out of the ground and using it for a fuel. The burning of fossil fuels, whether it's coal, oil, or natural gas, has released this very, very old carbon back into the atmosphere a lot faster than the oceans and the plants on the land can take it out of the atmosphere. It's bit by bit moving the Keeling curve up. In 1989 was the last time we saw 350 parts per million. And it appears that 2016 will be the last time that CO2 has dipped below 400 parts per million. And what the heck is 400 parts per million? What does that even mean? Well, we know from the analysis of ice samples from Antarctica that before the Industrial Revolution, the amount of carbon dioxide in the atmosphere was about 275 parts per million. It had been this way for thousands of years. Something has increased the number from 275 to 400. We're quite certain that that is due to the human activity of burning fossil fuels.
I take these satellite measurements and the variation over time of how the world is changing as facts. We've seen this warming over the last century and a half, very, very meticulous measurements, and it shows a really sharp acceleration in the warming over the last 4 decades.
People have a hard time understanding what's a big deal for a planet that is warmer by a degree or warmer by 2 degrees Celsius. But the impacts that we're worried about are being triggered not at a 20-degree warmer world, but they're being triggered at a 1-degree warmer world.
Over the last decades, we've seen the ice melting. We've seen the ice melting at the North Pole. We've seen the ice melting really fast on Greenland, where it's falling off Greenland into the ocean.
We've had Pacific Islands that have already had to be abandoned because of sea level rise. We can combine our data with global climate models and say, how is sea level going to change over the next 5, 10, 15 years? Because if we continue on the path we're doing, there's going to be a lot of coastal communities all around the world that are going to be flooded.
As scientists, we're just taking the most precise data that we can. It's open data, it's factual. For instance, the enormous droughts and fires that we have around the world are directly related to a warmer planet. That has a huge impact on people. It's unprecedented.
If you have a warmer atmosphere that can hold more moisture, because that's what warmer atmospheres do, they can suck up more moisture, That means more convection, more big thunderstorms, more hurricanes, more extreme weather. That's one of the likely outcomes of a warming world. We've built our civilization around the current climate, our coastal cities, our food resources, our water resources. They're all pegged to the current climate, and there's not much slack in the system.
We're already seeing impacts, and impacts are going to increase. In a 2-degree warmer world, there'll be more. And in a 3-degree warmer world, there'll be even more. And when you're looking at those kind of scenarios, 3, 4, 5 degrees warmer, which are totally plausible, if we go down that path, we will be looking at a different planet.